If you go on the web, go to Blackboard. Oh, you go to Blackboard, the slides are out there. You can blow them up as big as you wish.
Okay, wait a question.
Yes.
The -35 to -10 area?
Yes.
So that's where the transcription complex is all, that's where the initiation starts? That's the same as the data on a periodic?
Basically, yes. It's very simply, the -30, the polymerase, the RNA polymerase is a big honking enzyme. It straddles the DNA. It, sets right on top of it. That protein interacts with the DNA at 10 bases and 35 base pairs upstream from the start of initiation.
With the sigma factor?
With the sigma factor. And that's where the polymerase really interacts with the DNA and says, okay, this is a promoter, we want to start transcribing. Well, the start site of transcription is a little ways downstream, and that -35 and that -10, the nucleotide sequence there, if it is the consensus sequence, it is TTGAC, TATAAT. And if that is the consensus sequence of the -35 and the -10 region, and the closer you are to that consensus, the more expression you will get from a promoter.
The stronger.
Yeah, the stronger the promoter activity, yes. Good?
Okay, but so there's a promoter in prokaryotes, but in eukaryotes, it's just called a data box or an enhancer?
Yes, yes, because in the eukaryotes, there's this entire complex. It's the TATA box, it's a transcription factor, da 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 da. How many are there, Jay?
Well, I think Daniel's point is also that you have these enhancer elements that are throughout 50, 100 kb away.
Way.
Right.
Yeah,
So, yeah.
but they're not in prokaryotes, though?
No.
No.
There are enhancer elements in prokaryotes, but they're few and far between, and they're not 50 kb away. They might be 5 kb away, but they're very few. There's not a lot of them. They're much more common in eukaryotes. Yes?
By consensus, do you mean, is it conserved throughout all?
The consensus is you get 100 promoters from bacteria, and we'll all line them up at the start of transcription, +1 right here. And you see a certain sequence popping out at the -35 and -10 region. And that is the consensus sequence.
Do we memorize that specific sequence?
No,
Oh, no.
just I just happen to throw it out because I know what it is. Yes, sir.
How much details can you go in about the lambda repressor?
Lambda repressor. What do you want to talk about the lambda repressor? Lambda repressor has multiple functions. The basic concept there is that the lambda promoter that we talked about has multiple operator regions. If you bind at the first one, where it is upstream from the promoter, the regulator will bind that operator region and enhance binding of the RNA polymerase, and it will act as an activator. The next operator is a little further in and overlaps the promoter region. If the repressor binds there, it acts as a negative regulator and inhibits RNA polymerase binding by steric inhibition. Is that good? Cover everything you need right there. Yes, sir.
All right. I might have missed this, I just kind of walked in, but
about the consensus sequence,
Mhm.
in the promoter, okay, the -35, -10 is within the promoter, correct?
That is the promoter region.
Okay, that's promoter.
Yes.
The consensus sequence is where?
It is the -35, that little nucleotide sequence I rattled off a second ago. That is the conserved sequence at the -35 and the -10 region. If you look at 100 promoters and start looking at which bases are there the most, you will find the consensus sequence.
So are the consensus sequence within the 35 and 10?
Yes.
They're within, so the consensus sequence is within. So why are you, there was a statement that said the closer you are to a consensus sequence.
Okay, because promoters aren't always the same. It may be TTGAC in the -35 of the consensus. But another promoter that is not consensus may be TTC instead of a G. It may change a base or two in there. As it changes those bases, the expression level goes down.
So are you saying sequence similarity and not
Yes.
proximity flows?
No, it's sequence, it's the exact sequence in
I
there.
think we all thought you meant nucleus
Physically.
and proximity.
He does.
Oh,
No, it's not proximity. It's exact sequence right there. Okay.
Say that again.
Okay, does that answer your question? All right, okay, we were on different wavelengths. Thank you.
Can you summarize what you just said?
What?
Can you say what you just said in one thing?
Okay, that the -35 and the -10, there are different sequences at that region. If you line up 100 promoters and look which bases are there most often, you will get a consensus sequence, which is TTGAC, TA, blah, blah. Okay? The closer your promoter is to that sequence, the higher the level of expression. If you move away from that sequence in those two boxes, the expression level goes down. All right, is that good? Have we beat that to death? Yes.
My question is about transposons. In this figure, there's one that has 4 insertion sequences. Like normally the transposons have 2 insertion sequences at the end. In the event that there are more than one set of insertion sequences, which one dictates where it's inserted?
Which one dictates where
Yeah,
it's...
like how does it work when you have more than one set of insertion sequences?
We don't need to go there.
Okay.
We don't need to go there. It takes the outside one, it moves as a whole group. It moves into sites of homology. We don't need to go there. Yes, sir.
Do we need to know the specific location of operators on different genes? You have like a slide titled operator positioning, and sometimes the operator's in the middle of the promoter, sometimes before, after.
If an operator is in the middle of a promoter, what's it going to do? It's going to be a repressor. If it's upstream of the -35, the promoter, what's it going to be? It's going to be an activator. That work?
Yes.
I have a question.
Yes, sir. Yes, ma'am. Excuse me.
Okay, so I just want to make sure I'm right. With the prokaryotes, the transcription starts between the -10 to the -35 sequence.
Transcription starts at +1.
Well, okay, so one above that, one in front of that.
Yeah, +1.
Okay, and then, let me write that down. And then for translation, it starts at the Scheindel-Garno sequence for prokaryotes.
Okay. The Scheindel-Garno sequence is not the spot at which it starts translating, excuse me. Scheindel-Garno is the ribosome binding site.
Oh, the original binding site.
The ribosome binding site where it binds to the messenger RNA, and the first base that is translated is a little bit downstream.
Okay,
It's
because,
approximately 8 to 10.
okay, is that where, like, you know how it, like, scans it? Would that be, like, where it binds the scan?
Yes,
Okay,
yes.
but what about with eukaryotes?
Eukaryotes,
Gotcha.
I'm a prokaryotic guy.
Okay,
You're basic.